name's Kieran Jacobsen. I work for HP Enterprise Services for the Bank of Queensland account. I'm an infrastructure architect now. It's changed over the last week. Basically, I don't do security stuff on a day-to-day basis. It's something, though, that when you're working for a bank, you come across it again and again and again. It's something that nearly all of us on the account have to deal with it on a day-to-day basis. Automation is another thing. If you haven't seen in the news, HP is downsizing, which means fewer of us have to do more work. And so automation is a big driver for us. PowerShell's been something we've had to embrace quite heavily. So the aim today is just to show you a bit of what PowerShell can do in the security space, how we can take this nice automation framework and turn it into something that Microsoft never considered. So how many of you know what PowerShell is? How many of you have used PowerShell? So there's quite a few of you that have. In a nutshell, it's a scripting language. But it's a scripting language with a few quirks. It's something that's been crossed with a structured programming language. It's part Bash script, part C# code. It's got full access to the .NET framework. It's object-oriented, which is very different from a lot of shell languages. And it has the advantage that Microsoft has put millions upon millions of dollars of research into. They really wanted to outcompete Linux, so they threw as much money as they could at it. And this has meant that it has some really cool side effects for us. So how am I going to show you today that we can turn PowerShell into a very interesting and mischievous attack platform? I'm going to work through a challenge that was given to me by a friend who was previously actually working at Cert Australia. And he talked about how could we use some sort of built-in tool to move from a socially engineered infection on a workstation through to a domain controller and then get the hashes out of Active Directory. And to top it all off, to make it a bit more difficult, let's use PowerShell code wherever possible. When I first did this challenge a few years ago, there was a little bit of PowerShell and the rest was pulling down third-party tools, like PW dump and those sorts of tools. Nowadays, it's only when I come up to talking to Active Directory and the Active Directory database do I actually use an executable. The rest of it is pretty much all PowerShell code. And it's dramatically changed over the last 3 or 4 years. The demo environment I'm using today isn't a secure corporate environment, but it's a corporate environment that I've seen far too often. We've got a Windows 8.1 client, we've got that's domain joined, we've got a server that's running Windows Server 2012 R2. The domain's default config. Like a lot of environments, we've still got users that the local workstation users have admin rights. We've got a service that's running on that environment. Like a lot of environments still, and a lot of companies, that service account, whilst it's a named account, is a domain admin. And this is something that everybody scoffs at in this room. We all know it's a bad practice, but I've come into too many shops and seen SCCM in particular running as domain admin. And I've even seen web server farms of late with the web services running as domain admin. I completely lost it when I found that out. The demo environment is protected by a UTM firewall appliance. That firewall is a little bit locked down. It's still pretty much the default config. It's only allowing DNS, HTTP and HTTPS outbound. It's doing a bit of content filtering. It doesn't really allow most executables through. I have to do some trickery to get that, but PowerShell does it all for me. The only thing that's changed in this challenge since I first worked on it, back on Windows 7 days, is the stance incorporations around UAC. 3 or 4 years ago, most organisations with Windows Vista and Windows 7 were rolling out their environments with UAC switched off. If you do that today with Windows 8.1, you lose all your Metro apps. So you've got to have it on to some degree. And all that does is make the first infection a little bit more difficult. Once we've got a toehold into the network, once we've got that first workstation infected, everything else falls from there because UAC doesn't come into account. So why use PowerShell as an attack platform? PowerShell code is really easy to develop. It's very easy to understand, it's very easy to read. We can also rapidly change our code to meet our needs. It's that the intended target is using an antivirus platform that might be picking up some of the things we're doing. We can just go in that code and change it. It's really quick. It's also really integrated with Windows. Microsoft wanted PowerShell to touch everything in the Windows and server space. There's not a single Microsoft product out there now that PowerShell can't in some way manipulate and control. And that's really handy for us. Microsoft have also loaded in a whole bunch of ways of getting PowerShell code to be executed across all of your environment. There's a lot of different remoting options, and we'll talk about that shortly. The big problem with PowerShell code is that the antivirus companies haven't really caught up. They don't suspect PowerShell code to be malicious. We suspect VB script, we suspect batch scripts, we suspect anything that's .exe. But .ps1, which is a PowerShell script, we pretty much overlook. There's been 2 cases so far in the wild of malicious PowerShell code. I think that count over the next few months will probably start to grow as people start to realise what we can do with it. The other advantage is if you block all your executable content downloading through your proxy servers, that's fine. It's a plain text file. You want to block all plain text going through your web servers and your web proxies? Good luck. Another thing is that because Microsoft is forcing administrators to use PowerShell, your Windows admins, your Exchange admins in particular, are writing a lot of PowerShell scripts. And it can be very easy for an attacker to hide one more script in a big pile of scripts on a server, on a web server, domain control, even a user's workstations. Users and administrators are starting to expect to see PowerShell scripts on their clients and on their servers. One more, they're just going to overload it. The big thing though is it's there by default. Since Windows Vista, we've had PowerShell installed. Since Windows Server 2012 and 2008.1, we've had a lot of the remoting functionality now enabled by default as well. So it's there by default. Why not use something that's there? So I wrote a little script, and I've spent a bit of time revisiting it from every few months. And I suppose you could call it malware. If it's running on your system, you can basically start sending it commands, and you'll be able to run whatever commands that script's running as. So if it's running as local system, then you can run as local system, and that's what we'll be doing today. I've called it systeminformation.ps1. The aim with this name is just so that people look at it and go, it must be something harmless. Today I'm running it as a scheduled task. I've got an Excel macro that will drop it onto the client machine, and it's just going to create a scheduled task that runs every 5 minutes. Every time it runs, it's going to do a few things for us. Firstly, it's going to gather a whole bunch of system information that might be useful to us. It's then going to go off and collect some poorly secured, poorly protected credentials off that system. Once it's done that, it's also going to go off and talk to a web server that I've got running up, a C2 server, so to speak. It's going to pull down a task list off that, and it's just a simple CSV. Tasks can be anything that's valid in PowerShell. More PowerShell code, another executable, .NET framework code, anything we want to run. And we can filter that task list down to run on specific machines. So, let's try and see if the demos will work.
Sacrifices.
I've done quite a few because it's their Microsoft demo guide, so they require a bit more blood. Right, so just to begin with, I've got the program data directory folder open. As you can see, nothing here. If I just go over, our attacker has convinced our victim here that there's some reason for them to open this Excel spreadsheet. So they're going to open the Excel spreadsheet. Of course, it's macro embedded. As you can see, it's some sort of bug tracker. That's not what we're interested in though. If we minimize this, you can see that it's already downloaded our systeminformation.ps1 script. So we've already got the script now on the system. We're already starting to execute it, and it's starting to create some individual folders and some individual information. It's already starting to go off and collect the system information that we need to do. It's doing this in a multi-threaded manner, so I can actually start searching through the registry, the file system, and do all the C2 infrastructure in parallel. This is all native PowerShell code doing it. So in a few minutes, we should see over here on my C2 server, let me just minimize this one. So we've now got on my command and control server a user pc.txt file. So all that PowerShell processing is just completed. It's bundled it all up in a text file and uploaded it to the web server. We take a quick look in here. You can see we've got our standard basic system information, host names, what OS it's running, what CPU, memory, OS architecture, and that it's a member of the domain. We can also see that we've got internal, so the local IP config here as well. Where's my page down? You can see that we've got external IP address here. Now that's blank at the moment. If this was externally running, the PowerShell code that I've got would actually go off to a web service that's a public web service that will tell you your IP address. So now we have internal and external IP address information. We've got DNS server information, disks, volumes, all the services that are running on the system as well. And you can see it's a standard Windows 8.1 machine, so there's quite a lot. We've then got wireless LAN profiles. So if this was a laptop machine, we could probably see a whole bunch of the different, free Wi-Fi, the corporate Wi-Fi networks, they've all joined. The commands I'm running will actually also give you the passwords for those wireless networks. Really handy info. I've then got a dump of the local administrators, always handy. Because we're on a domain, I can then start going off and querying some stuff about the network, about the domain. So who's a domain admin? We've got this lovely service account called a service account. Smart admins, good naming convention. We can also see that we know what the domain controllers are, because that's another group. So we know now the name of a domain admin user and a domain controller. Next, I've got a listing here called winscp.ini and winscp session, registry session information. A few weeks ago, I had a colleague come to me about a security audit. He was in a bit of a fluster, and he said, they started to ask me how we're protecting our SFTP server details. And I told the auditor that it was all secured in WinSCP, and he laughed at me. Why did he laugh at me? It's very easy to find WinSCP session information. And there's a Metasploit module that will allow you to decrypt all of the passwords if you've selected that option to save them. I simply got the Metasploit module, looked at the code, reversed it, engineered it so it runs on PowerShell. And so now there's a PowerShell module that will convert these passwords out for you. The script here is literally just trawling through the registry, trawling through the file system, and finding these chunks of information. If it finds them, it dumps them out. If it finds private keys to sessions, it dumps those out as well. It's all pretty basic stuff. The last lot, though, is where things get a bit more interesting. Oops. LSA secrets and NT user hashes. Microsoft about 2 years ago did a blog post on using PowerShell for security reasons. Most people didn't read it. The first three posts are pretty useless. They're actually quite rubbish. On the fourth one though, things became very interesting because they blogged about how to use PowerShell to duplicate the security token of the LSASS service. Once you've got that, you've got pretty uber power on the system. The next blog post, they actually talked about decrypting the LSA secrets. They gave us all this code for free. You don't need to download pwdump.exe anymore to get this information out. Just use PowerShell. Go to the Microsoft site, use PowerShell. One of the security companies that's associated with Microsoft extended this further. And then they worked out some nice PowerShell code to also get the NT user hashes out. So without doing any executable code, you've got the LSA secrets, you've got the Windows NT hashes. Now that we've got the LSA secrets, we've got a username and a password for the domain. And we already know that's a member of domain admins. That's pretty much obvious what's going to happen from here on out. But we'll do it anyway. So I'm just going to close this down. So what I want to do now is infect the domain controller. I want to get access to the domain controller. So I need to somehow get my script running on the domain controller. So I need to tell that infected Windows 8.1 machine to go off and run some code that will download that script on the domain controller and infect it for us. We turn to PowerShell again, it's going to do this. I'm going to just add a command into the tasks list, and what it is a fairly simple one-liner. And what this is doing is it's calling a PowerShell function within my script called remote install. It's feeding it through 3 parameters: a username, a password, and a machine to infect. That's all we need to go off and get domain controller access. What will happen is the next time that script runs, the user PC will go and download this task list. It'll say, hey, I've got something to do, and it's going to execute this command. And within the next few minutes, we should see the server check-in to this directory. So probably see it in probably 5 or 10 minutes time. While that's happening though, I just want to quickly talk about some other things. So Windows PowerShell remoting and WinRM. PowerShell remoting has been a very interesting thing that's happened over the last few years in Microsoft security, and it's something that a lot of people didn't realise has happened. PowerShell remoting is based upon a tool called WinRM, or Windows Remote Management, and it's Microsoft's version of the WS Management Web Services. They're an open standard allowing clients to basically connect into a web service and start running commands on a local system. It gives us a number of different ways that we can run code on a remote server. PowerShell commands have been extended to support it. If we don't want to do that, there is a feature in PowerShell where we can simply get a bundle of code and go, hey, go and run this. We can also, much like using PuTTY, open a full session. We can have just a console, and that's the remote session. So much like you'd fire open an SSH session or PuTTY, you can have a remote session with a Windows server. It's got a very flimsy security model, WinRM. Firstly, you need to be on a trusted device to connect to the remote machine. A trusted device in Microsoft language is anything that's joined to the domain. If you're a domain member, you're trusted. Woohoo! You need to have the appropriate user credentials as well. And that basically means local admin, or in my case, domain admin. But here's the real kicker with it all. In the past, admins had to configure this. With Windows Server 2012 and 2012 R2, Microsoft introduced their new unified Windows Server Management Console. You put all your machines in there and you can manage them all from one single pane of glass. To do that, you need to have WinRM. They realised that Windows admins were lazy bastards. So now when you join a Windows Server 2012 or Windows Server 2012 R2 machine to a domain, it automatically configures it all for you. So this lovely security hole is open for you by default. In the old versions you had to configure it. Now Microsoft's doing it for you. Most admins haven't realised this. Most security guys haven't realised this. I didn't really understand the full extent of this until about 3 weeks ago when I started as president. So let's just go and see if that domain controller is now infected. As you can see, the demo guides are actually shining today. It's a Windows Server machine. You can see Windows Server 2012 R2 data center. If I scroll through the server listing, the services listing, I should have some domain services. DNS servers definitely running, DFS namespace is running. Pretty good sign that I'm on a domain controller. So what's the next step? Well, I need to get those Active Directory hashes. So what I'm going to do is I'm going to add another command to that commands.txt. And this is even simpler. It's called get AD hashes. This one is a little bit longer. Microsoft aimed with PowerShell that every function, every command you call, it should be obvious what it does. And that's why they have this get blah, set blah naming convention. So of course, get AD hashes does exactly what it should do.
Do they just have an own everything?
Pretty much. So what does get AD hashes do? It firstly does a volume snapshot on the domain controller. It then copies ntds.git. It then downloads Quark's PW dump so we can actually start fiddling around with the AD database. It cleans up all of the volume snapshots so there's no evidence we've done anything. It then, of course, extracts the hashes out using Quarks. Once it's got the hashes, it's going to send them up to our command and control server. So I'm just going to close this minute out, and in a few minutes, once again, if the demo guides decide to obey, we should see a folder in here with the hashes. Whilst we're waiting on that,
It's like watching a cooking show.
So quickly on to security in PowerShell. Microsoft have pretty much stuck to what we all expect in terms of security. You've got your administrative rights. If you needed local admin rights before PowerShell, you still do today. UAC, if you needed to elevate, you still pretty much need to elevate today. The things deviate slightly when it comes to the last three components. Yes, you can sign your scripts you can use authentic code signatures to protect your scripts and your PowerShell modules. The other thing that PowerShell does is it looks at the NTFS zone.identifier alternate data stream. Now, for those of you that don't know, that's the little annoying thing that when you download an executable off the internet and try to run it, it goes, do you want to run this application you found on the internet? And you go, yes, go away. That's the zone identifier. PowerShell reads this. And when we combine that with code signing, this is where we come up with the Microsoft PowerShell execution policy. The PowerShell execution policy was Microsoft's attempt to stop us doing bad things with PowerShell. It doesn't work. We can specify the execution policy in 3 different levels: at the session, at the user level, and at the computer level. It's stored in the registry, and we can override that and also manipulate it with group policy. Let's take a quick look at the different states. So there's 6 different states Microsoft decided to define. The first we have is unrestricted. Let's run anything we find. Any PowerShell, let's just run it. Pretty much, you'll find that probably half your servers in your environment are running at this level. Your Exchange servers will be, because the admins will have gone onto the console, nothing will work, and they've gone, PowerShell execution equals unrestricted. The next level we've got is remote signed. If it's validly signed and it's from the internet, I'll execute it. If it's from the local machine, I'll execute it. If it's not signed and it's from the internet, I won't run it. That's the idea with remote sign. Microsoft recommends this one. The gotcha with this one is as long as it's signed by somebody you trust. And once again, we come back with the problem with macros. It's anything that Microsoft trusts, which is all the VeriSign code signing certificates, anything by Thwart, anything by any of those major third-party CAs will still run.
Like Turkish CAs, right?
Pretty much. The Turkish CAs, the German CAs, the Syrian CAs, it'll all run.
The Shanghai Post Office.
Yeah. All signed is the next one. And in this case, it's very much that even if it comes from the local machine, it needs to be signed. That's the only difference. It's still just as insecure. We've then got the most restrictive level, and that's restricted. In restricted, we're not going to allow any PowerShell scripts or modules to be executed or run. We've then got 2 special states, undefined. This is your system default. It actually is restricted, but Microsoft likes to label it differently. I don't understand. Finally, you've got bypass. Bypass is essentially where you've told PowerShell, don't run the execution policy at all. This is the holy grail. If you can set this, you're done. Because now you're not even bothering to look at any of the signing information. And you don't look at any of the signing information either. So if you've got a forged authentic code signature, it ignores that. An obviously bad piece of code that's got an update, and maybe somebody's gone in and just tinkered with a site and script. That shouldn't run. In this mode, it will. Bypass was put in for when you want to run PowerShell scripts from a third-party executable. That's why they put it in there. Microsoft heavily leans on bypass for all the Exchange code, all the Exchange management consoles, and all of System Center. If you try and restrict an Exchange server to run all signed, you will not be able to use Exchange anymore. The admin consoles don't load, service packs don't run. Because it tries to go into bypass mode, it fails and the setup stops. If you do that on an Exchange 2010 box during the Service Pack 1, you end up with no Exchange installation in your environment. Because it does the uninstall, tries to do this and fails. Lovely issue that Microsoft introduced. You're probably saying, sure, these might sound secure. You can actually bypass all of these, including restricted. And the tool you use to bypass them is PowerShell. So, depending on what the admins have configured, you can simply say to PowerShell, hey, I want to use a different policy. And if the administrators haven't done anything, PowerShell will let you do that. You simply say execution policy, unrestricted, you're now unrestricted. If you're insane, you could say restricted or all signed. If the administrators have set remote signed, they're thinking they might be able to get around the fact you're downloading stuff off the internet. You just ask PowerShell to unblock the file, and that removes the zone.identifier. Don't need to sign it, just unblock it. Done. If they've set all signed, or if they've set restricted, and they've set that in group policy, things become a little bit more difficult. But once again, you can call PowerShell to your rescue. You ask it, instead of executing a script, to read it into memory. And it'll read it in as a giant file with multiple lines. Then go through it and actually make it a single one-line PowerShell script, one-line PowerShell expression. Then you say, hey PowerShell, run that. And because it's not a script file or a module, once again it runs it. The other thing which a lot of people seem to think isn't possible is just getting a certificate. I've done this demo in corporate environments. I've asked for code signing certificate beforehand. They've given me one, I've just signed all this code. And then it runs as well, even when you've set all signed. Stealing certificates have been happening more and more. You know, how many times have we heard people say, hey, the Google certificate's been, cracked, or somebody's gotten into a third-party CA and issued certificates. It's not just SSL certificates they're issuing for web servers, it's also code signing certificates as well. So let's see. Have the demo guides. So there we are. We've got the domain computers, the domain users, service counts, the Kerberos hashes. You just load up Kane, get crowdcracker.com, looking at it. Crowdcracker.com, if you haven't used it, it's about $20, and in about an hour, even a 200 or 300 user list will be about 60% cracked. It's made by Moxie Mar and Spike. It's a very nice little project, and it's dirt cheap. It's about 10 or 20 bucks. So, just to round up things, there's been a few other changes by Microsoft. Two other things before I finish that you need to consider. One is PowerShell web access. Microsoft added this so that administrators could work from their phones. It's a web browser page that you can go to, you log in, and you can run PowerShell code. Now, sounds kind of useful. No. It's just a Windows feature you add like anything else. All you need is iOS installed. I can see this being very entertaining if you're doing a pen test on, say, DMZ web servers. Add the feature in. Now you've got a console. You don't need to have something phoning open or reverse shells. You just log into a console via the web server. They are looking at extending this so that it can also be used as sort of a bastion host style thing where you can use it sort of like a proxy server into your environment. And once they do that, it's going to be even easier. That's probably scheduled for maybe update 1, no one really is certain. The final feature that's worth looking at is the desired state configuration, or DCS. DCS is sort of like group policy, but it's designed for servers. You can tell a server to either pull a configuration or you can push a configuration to it. Configuration items can be application installs, registry settings, files, scheduled tasks, Windows features and more. And every cycle period that it goes to do this process, it's going to pull down the config. The admins can go and uninstall your malware or your backdoor. DCS will run and reinstall it for you. Microsoft are really pushing for the idea of a central policy store with that. So that means you get access to that file share somewhere in the internal network and just start rewriting these files. Really nice little vulnerability they've included there. Group policy gave us enough ways of getting into a system, now we've got DCS as well. So, that's pretty much me done. I knew there was going to be a lot of questions, and I thought if we had time we could look at code. I've got my blog, which is aperturescience.su. All of the code is up on GitHub. You can go there tonight and download it from there. All the examples are up there. Take a look at that. I've got links to Quark's PW dump. Powershell is a really interesting project that's being run by some security blokes. They've gotten a whole bunch of various security-related PowerShell code and stuck it all in one GitHub repository for you. There's demos, there's docs, everything's there on the spot. Just go and take a look at it. I've gotten a few things from today's prezo there, and there's a few things I'll be channeling back up into there as well. I've then got a list of the very boring first three sections of the Microsoft PowerShell security blog series. I've then got the two interesting ones at the bottom. The final link is to a practical persistence in PowerShell. A pen tester, and his name has completely jumped my mind at the moment, has written a bunch of code around persisting various backdoors using PowerShell. And he talks about scheduled tasks and registry and file systems. He also goes into great detail about using PowerShell to hook into WMI event processing. And that's a really nice way of keeping your script and your code running, even if the sysadmins try to reboot and do all sorts of things like that. So, if anyone's got any questions, I hopefully will be able to answer them.
Well, first of all, I've got a question for everyone else here. Who's terrified? Yeah, I actually have a question, which is, you showed the first point of the attack was to stuff all this stuff into an Excel file. But by default configuration, I mean macros are disabled, aren't they?
So by default they are. I work in an organisation that's pretty much run off Excel spreadsheets. HP is Excel macro obsessed. And that's where I got the idea from. We have one manager that can't survive without them.
So assuming that your target is not allowing macros to run, what would be the next sensible way for dumping your PowerShell script on a target?
Pretty much any way you can execute code. If you can get it, a call off to PowerShell to say, download this file and create your scheduled task, you're done. Do I have demo
So
code?
executing a code or even a command?
Even a command, yes.
Okay, so if you can get command execution, you can do this.
Now, let me just show up the code that actually does the... where did I go? So this is the actual script, and it's quite long. Let me just search for it. Didn't find it. Hang on a sec. Sorry, I cannot find it today. There is a command here somewhere that will do it. Simply put, PowerShell, because it accesses the .NET framework, you can simply say run this .NET command, and that's a download command. And then the next one you need to run is create the scheduled task, and it's literally 2 lines of code. And you can do them all in one line on the command line. I really wish I could find it.
Even so, that though, you set down a social engineering spreadsheet that's got any name that makes sense, and it goes, this is macros enabled, do you want to run them? Even with them disabled, they go, yes.
Well, I mean, I think you can disable that through group policy.
No organization bigger than 10 users blocks it because everybody writes macros for their spreadsheet, so you can't force it off on the business.
Okay, well, I'm back to being horrified, thank you.
I've actually got one senior manager that he writes macros in such a poor way that you need to be elevated to run them. He creates temporary files all over your hard drive, and you need to elevate, and that's even more scary because
Just target sysadmins. It's
Yeah.
an HP configurator.
yes, how many people have bought a HP server and used the HP configuration tool?
We've got a question down the back there.
Yep.
Before in your presentation, you asked, you said that it's done for conversion together, so R1 and R2. Is that the AD functionality level or just the operating system?
Just the operating system level.
So
So
they could be joined to plus the 2008 and 2003 levels and
true.
have that service.
Yes. The server manager to run uses WinRM. So that's why they enable it when you domain join.
Sorry guys, can we just, we've got a
But
question.
on that same screen then, if you have a 2012 level domain, does that then go and activate that on all the servers?
No. But the interesting thing is that if you install the latest Microsoft management framework, which installs PowerShell 4.0, it will also do that as well. Enable it, yes. So if you've got a fully patched machine and you're an admin that goes, hey, I want the latest version of PowerShell on there as well, and push out that update, that'll be configured on your 2008 R2 servers as well, yes.
Have you spoken to Microsoft about this?
This is a lot of stuff that they've been aware of for a while, but it comes down to that usability thing. And they want usability over security at the moment.
They will I'll be hearing a little bit about this.
I'm just going to say, if you consider creating WinChef here, this is basically like remote execution for Windows. And, let's just take it a step further.
Extending this code will be very easy for multiple things, yes.
All of the things. I think everyone's a little bit shocked. We might need a move. Question over here.
Does this rely on the target being localized? Like what happens is
For that initial infection, yes.
Okay.
But if you can get a hold some way, then you can use WinRM to jump through, and that's the big thing. And this is the big part of what I want to show today was the WinRM component, because that's what allows you to reach all the other machines in the domain.
So I imagine this would be most useful as a somewhat stealthy lateral movement technique, right?
Yes.
Yeah.
Can that be extended by some sort of privilege escalation, or does it have to actually have credentials in AD?
You don't need to, but you could certainly try some privilege escalation tactics, yes.
But I mean,
For WinRM to
you
run
don't
it,
have the local admin.
all you need, well, for WinRM to successfully connect, you do need local admin rights by default. Of course, if admins change the default settings, who knows?
Yeah, how are we doing for time? My phone's charging. 5 minutes to go. So any more questions? My God, we might actually have a five minutes for OJ to actually set up his computer before the kicks on. Everyone thank Kieran. I think that was a splendid talk.